Hi friends, good morning. Good morning Narendra. Am I audible? Am I audible guys? There is only one person, that is Narendra. What about the other guys? What about the other guys? Only one person. It shows that 5 people are watching. One is me and Narendra. Who are the other 3 guys that is watching? Now 6 people are watching. Please do comment guys. Akhil saying good morning Akhil. Good morning Akhil. I will start. I am just waiting for people to come. What happened? There are no people. Good morning, my flute school. Good morning, good morning, good morning, my flute school. What happened, guys? No crowd today. So we were discussing highway materials, and highway materials In the highway metals yesterday we have discussed coarse aggregates mainly, and what are the tests to define the to find out the properties of the coarse aggregates. Now we will be seeing bitumen, right? Today also we are discussing highway materials. In highway materials, today we will be seeing bitumen, right? Bitumen. Before that, first we will try to see what is the difference between bitumen and tar. Bitumen and tar both looks in the same color, but there is huge amount of differences between bitumen and tar. Fine. So bitumen is obtained from bitumen is obtained from fractional distillation of petroleum. Bitumen is obtained from fractional distillation of petroleum, whereas tar is obtained from destructive distillation of coal or wood. Tar is obtained from destructive distillation of coal or wood. Tar is obtained from destructive distillation of coal or wood. So distillation is the process where we are going to separate materials into different things. That means if you are getting petroleum ore, after distillation we will be getting petrol separately, diesel separately, bitumen separately, like that. So that is where you will be getting destructive distillation, fractional distillation. It's the methods which is not important from ESE point of view. That's why I am not discussing over here. But anyway, distillation is the process where we are going to separate the materials. So if you do fractional distillation of petroleum, you will get bitumen. If you are doing destructive distillation of coal or wood, you will be getting tar. So both are from different materials. Okay. Next one is bitumen is soluble in carbon disulfide CS2 and carbon tetrachloride CCl4 and carbon tetrachloride CCl4, whereas tar is soluble in toluene. Bitumen is soluble in CS2, carbon disulfide and carbon tetrachloride, whereas tar is soluble in toluene. So from here you can easily differentiate between whenever a bitumen and tar is given to you, try to see in which one it is soluble. If it is soluble in CS2 and CCl4, it is bitumen. If it is soluble in toluene, then it is tar. Fine. Next. Bitumen has more resistance to water. Whereas tar has less resistance to water. More resistance to water, whereas tar has less resistance to water. Bitumen has more resistance to water, tar has less resistance to water, less temperature susceptibility, less temperature susceptibility, more resistance to water means it will not allow water to enter in it. So that is always better, right? If water enters into the highway, then what happens is there will be huge amount of drainage problems, ruts, mud pumping, all those occurs. Whereas it's like more water tightening properties, whereas less water tightening properties in tar. And here less temperature susceptibility, less temperature susceptibility, and more temperature susceptibility. With change in the temperature, the properties of tar changes, whereas with change in the temperature, the property of bitumen doesn't change. That is the meaning of temperature susceptibility, right? So more temperature susceptibility, less temperature susceptibility. Okay. Next one is free carbon content is less. In this free carbon content, everything will be consisting of carbon content only, but anyway, free carbon content is less and free carbon content is more. Free carbon content is more. So these are generally the properties of bitumen and tar, and they'll not in prelims they'll not ask you to differentiate, but they might ask you questions like which one is having more temperature susceptibility, or which one is more resistance to water, or in which one free carbon content is more, or bitumen is soluble in what, tar is soluble in what. So and how you are going to get the bitumen, how you are going to get the tar. So these type of questions might be asked. So it is discussed over here. Any doubts in this? You can go ahead and ask me. Any doubts, guys? No doubts? Fine. Akshay, Rana, no. Fine. What about the other guys? Only 3 people are watching. Why so? Why it is less? Fine. And if I try to see bitumen, in bitumen there are different types. First one is asphalt bitumen. Asphalt bitumen. Asphalt bitumen. If bitumen contains or if you are injecting inert material, if bitumen contains inert material, then it is known as asphalt bitumen. Then it is known as asphalt bitumen. If bitumen contains inert material, then it is known as asphalt bitumen. Okay, inert material means what? The material that does not react with anything, that is called as inert material. So if bitumen contains inert material, then it is called as asphalt bitumen. Next one is cutback bitumen. Cutback bitumen. Fine. So if viscosity of the bitumen is reduced, if viscosity of bitumen is reduced by adding volatile by adding volatile dilutants. If viscosity of the bitumen is reduced by adding volatile dilutants, then the bitumen is known as then the bitumen is known as cutback bitumen. Then the bitumen is known as cutback bitumen. Viscosity means resistance to the flow. That means you are adding some dilutant so that it can easily flow. It is easy to work. So that is the meaning of it. If viscosity of bitumen is reduced by adding certain volatile dilutants, then the bitumen is known as cutback bitumen, generally used in colder regions. Fine. So generally used in colder regions, that is cutback bitumen. Next you can see bitumen emulsions. Bitumen emulsions in this bitumen is present in this bitumen is suspended in an aqueous medium so that it can be used for patchworks. That means generally you have to do some patching, or you have to just use bitumen painting and all those things. Then what you will do is you pour this bitumen in water or in any aqueous medium. It can be in kerosene or glycerin, anything. You will put this bitumen on it, and once you put the bitumen, it becomes liquid, so that you use that liquid for patchings of the roads. For putting certain patches on the road, you will be using, for patching works or patchworks, we will be using bitumen emulsions or emulsified bitumens. Fine. And it can be used in rainy seasons also. Why? Because it is already watery, so you can use it in rainy seasons. It is not going to affect much. Fine. So any doubts in this? Asphalt bitumen, cutback bitumen, and emulsified bitumens or bitumen emulsions. What? Any doubts? Good morning, Prachi. Any doubts, guys? Please do like, share, subscribe with as many people as possible. Any doubts? Volatile dilutants like naphthalene balls, naphthalene balls, that can also be considered as volatile dilutants. Kerosene sometimes, that can also be an volatile dilutant. Dilutant means what? We are trying to dilute, we are trying to reduce the concentration of certain things, right? That is called as volatile dilutant. We are reducing the concentration of it, so that is the meaning of dilutants. We are going to dilute the bitumen so that viscosity is reduced. Viscosity is reduced means it can easily flow. That is the meaning of it. Now, any doubts? Akshay Rana. Fine. Next one is test for bitumen. Test for bitumen. Tests for bitumen. Tests for bitumen. So in tests for bitumen, what exactly you will be doing is, first one is penetration test. First one is penetration test. Fine. So penetration test. Penetration test. So what exactly penetration test represents is, generally what we will be doing is, in this we will be taking a bowl. In the bowl bitumen is kept, right? We will be taking a bowl which contains the bitumen, then we will try to pass the needle. A certain arrangement will be there. Let us say there is bitumen over here up to here. Fine. We will try to pass the needle, we will try to allow the needle which is carrying some weight. Let us say the weight that it is carrying would be generally 100 grams. 100 grams of weight would be there. 100 grams. This is needle, and this is bitumen at 25 degrees Celsius. Fine. What exactly we will be doing is, we will allow the needle to pass through the bitumen for 5 seconds. Depth up to which needle penetrates is measured. Depth up to which needle penetrates is measured. Fine. So that represents what? Softness or hardness of the bitumen. So that means if bitumen is harder, the depth penetrated would be less. If bitumen is softer, the depth penetrated would be more. Generally, the penetration test results gives the grade of bitumen. Grade of bitumen that is given as, let us say, 80 by 100. If I am saying grade of bitumen is 80 by 100, then penetration depth is in the range of 8 mm to 10 mm, 8 mm to 10 mm. 8 mm to 10 mm. If grade of bitumen is 80 by 100, that means penetration depth is 8 mm to 10 mm. Fine. That means when you allow the needle, it falls up to a depth of 8 mm to 10 mm. That is the idea of penetration test. So penetration test is used for the bitumens, is used to find out the softness or hardness of the bitumen by measuring the depth in 1/10 of an mm, to which a standard needle of having 100 grams is allowed to fall, or falls for 5 seconds, when it is allowed to fall for 5 seconds at a given temperature of 25 degrees Celsius. That is considered as penetration. That is penetration test, and grade of bitumen is generally given as 80 to 100. And we are not going to do this test for tar, because tar is already very soft. Bitumen is considered as hard compared to that of tar. So tar is already soft. We are not going to do penetration test for the tar. Fine. So that is the idea of penetration test. Penetration test. It represents softness or hardness of bitumen by measuring depth in 1/10 of mm, up to which a standard needle weighing 100 grams penetrates penetrates through the bitumen for 5 seconds at a given temperature of 25 degrees Celsius. So it represents softness or hardness of the bitumen. So by measuring the depth in 1/10 of the mm, that means if penetration test value is 80, then depth of penetration is 1/10 of 80, 8 mm. If penetration value is 100, then depth of the bitumen is depth of the penetration is 100 upon 10, that is 10 mm. Fine. So generally grade of bitumen, if grade of bitumen is 80 by 100, if grade of bitumen is 80 by 100, it represents penetration depth of 8 mm to 10 mm. 8 mm to 10 mm. Tar penetration test is not used for tar. Penetration test is not used for tar. Penetration test is not used for tar. Penetration test is not used for tar as it is very soft. Penetration test is not used for tar as it is very soft. Penetration test is not used for tar as it is very soft. If grade of bitumen is 80 by 100, then it represents penetration depth of 8 mm to 10 mm. Fine. Penetration test is not used for tar as it is very soft. Fine. These are the things, points that you can remember. And generally, if grade of the bitumen is given as A30. 30 means penetration depth is 3 mm. A, what does it represent means? Then it represents bitumen is from Assam Petroleum. It represents bitumen is from Assam. Bitumen is from Assam Petroleum. Bitumen is from Assam Petroleum. If it is S30, then bitumen is from other petroleums other than that of Assam Petroleum. That is the meaning of it. If it is A30, then bitumen is from Assam Petroleum. If it is S30, then bitumen is from other petroleums, not from Assam Petroleum. Why Assam? That means the product that you will get will be of more better quality. That is the meaning of it. So this is the penetration test. Penetration test indirectly used to measure what is the softness or hardness of the bitumen. If bitumen is so hard, then penetration depth would be small. If bitumen is soft, then penetration depth would be high. Fine. So grade of the bitumen can be given as 80. Just it can be 60 by 70, 40 by 50. What does it means is penetration depth is in the range of 4 mm to 5 mm. Any doubts in this? You can ask me. Any doubts? at room temperature how it will penetrate. That's why I am saying it is 10 mm. 10 mm means how much? 1 centimeter. 8 mm, 1 mm, 3 mm. That means you just allow it to fall, it presses like this. So, it presses, there will be small penetration. It is not like 1 meter, 2 meter penetrations, 1 mm, 2 mm penetrations. Think practically. Good morning, Bhaskar. Any doubts, guys? No doubt? Fine. This is penetration test. Next one is ductility test. Ductility test. Indirectly, ductility means here it is going to measure the elasticity of the bitumen, elasticity as well as adhesiveness of the bitumen, how much strong the bitumen is. Fine, how much elastic, like when you keep on expanding it, how much it can elongate. Ductility means indirectly what? Ductility is the property in which the material can be converted into wires, like the steel rod, it can be converted into wires after keep on expanding it. The same thing here, we try to expand the bitumen and we'll try to measure the distance up to which it can expand. Indirectly it measures the elasticity of the bitumen, or you can also say adhesiveness of the bitumen. Cohesiveness, adhesiveness, right? So, adhesiveness of the bitumen can also be measured by using the ductility. In this, what exactly we will be doing is, there will be a stranded briquette mold of size 10 mm by 10 mm. There will be a standard briquette mold of size 10 mm by 10 mm. Fine. So, there will be a standard briquette mold of size 10 mm by 10 mm. Fine. What we'll do is we'll keep on expanding it. We'll keep on expanding it till the time the thread breaks. Till the time the thread breaks. That means you'll keep on expanding it something like this. Something like this. Fine. So, you keep on expanding it something like this. So, this is given as ductility value. This is given as ductility. This is given as ductility. You keep on expanding it. This is 10 mm by 10 mm, not exactly, this whole thing is 10 mm by 10 mm, small square. You will keep on expanding it on both the sides and we will try to measure the distance up to which it can be expanded so that the thread breaks. So, the thread breaks. Fine. And the distance is generally measured in centimeters. For bitumen whose grade above 45, for bitumen whose grade above 45, the ductility should be equals to 75 centimeters. For bitumen whose grade is above 45, ductility is 75 centimeters. Fine. So, this you have to keep in the mind. Ductility test. Ductility test. it is defined as distance in centimeters up to which a briquette mold filled with bitumen, it is distance in centimeters up to which a briquette mold filled with bitumen expands up to which a briquette mold filled with bitumen expands, or distance up to which stretched so that not expands, a briquette mold filled with bitumen is stretched so that it is defined as distance in centimeters up to which a briquette mold filled with bitumen can be stretched just before the thread breaks. Yeah. The distance in centimeters up to which a briquette mold filled with bitumen can be stretched just before the thread breaks. Thread of the bitumen breaks. Fine. And it measures the adhesiveness and elasticity of the bitumen. It measures the adhesiveness and elasticity of the bitumen. Okay, that is one thing. Next point is it measures the adhesiveness and elasticity of the bitumen. This is your second point. And the third point would be ductility of bitumen. Whose grade is above 45, is 75 centimeters. Ductility of bitumen whose grade above 45 is 75 centimeters. That is ductility of the bitumen. So, any doubts in ductility of the bitumen, you can ask me. Any doubts? Any doubts, guys? No doubts? Fine. Next one is viscosity. Fine. So, what exactly is viscosity? Viscosity is the resistance or inverse of fluidity. It is the resistance to the flow. That means if I say more viscous means it flows very, very slowly. If I say less viscous means it can flow easily. right? So that is the meaning of viscosity. Viscosity is inverse of fluidity. Viscosity is inverse of viscosity is inverse of fluidity. It is the resistance to the flow. It is the resistance. It is the resistance to the flow. It is the resistance to the flow. So how exactly you are going to measure the viscosity is, we will take 50 ml of bitumen in a beaker, in a container or beaker. We will take 50 ml of bitumen. We will take 50 ml of bitumen in a container or beaker, and we will allow the bitumen through flow through the orifice. Allow the bitumen through flow through the orifice. So the time taken by the bitumen, time taken by the bitumen to flow through the, time taken by the 50 ml of bitumen to flow through the orifice is measured. If time taken is more, that means the viscosity is more. If time taken is less, that means the viscosity is less. Fine. So viscosity is measured viscosity is found out by measuring time taken by the 50 ml of bitumen, time taken by the 50 ml of bitumen to flow from beaker through an orifice, Viscosity is found out by measuring time taken by 50 ml of bitumen to flow from beaker through an orifice at a standard temperature of 25 degrees Celsius. So viscosity is found out by measuring time taken by 50 ml of bitumen to flow from beaker through an orifice at a standard temperature of 25 degrees Celsius. If viscosity is less, what happens is it can easily lubricate the aggregates. Lubricate means it can easily cover the aggregates. Fine. So it can easily lubricate the aggregates, but what happens is it has less strength. It will be having less strength. That is the major point, right? So if viscosity is less, it lubricates the aggregates. Viscosity is less, it lubricates the aggregates. But strength obtained will be less. So if viscosity less, it can easily lubricate the aggregates, but the strength obtained would be very, very less. Next point is, that is, if viscosity is less, it lubricates the aggregates, but strength obtained would be very, very less. If viscosity is more, then what happens is bitumen will be hard and stiff. It can easily take the load, but what happens is material mixture will be homogeneous. That means bitumen will be separated out, concrete aggregates will be separated out, fine aggregates will be separated out. That means it will not lubricate the aggregates, it will not go and fill the voids. What happens is bitumen will be separate, coarse aggregates will be separate. So the mixture would be heterogeneous. That is the problem. If viscosity is more, then it takes compressive stress, but if viscosity is more, it takes compressive stress, but mixture will be homogeneous. Generally viscosity is given time which is given in minutes. Fine. So time is given in minutes. So viscosity, if it is more, then it takes compressive stress, but the mixture will be not homogeneous, heterogeneous. Heterogeneous means like different particles. Heterogeneous. It will not act like a single unit. Bitumen will act separately, coarse aggregates will act separately, fine aggregates will act separately. So mixture will become heterogeneous. If viscosity is more, then it takes compressive stress, the mixture will become heterogeneous. If viscosity is less, then it lubricates the aggregates, strength obtained would be less. Fine. So any doubts in this, you can go ahead and ask. Any doubts, guys? No doubts? No doubts? Same doubt, it is room temperature, it is possible to fall. That is what we will be seeing at how much amount of time. Slowly, very slowly it will fall, very slowly. You will heat the bitumen and you will keep it in the room temperature. It's not like you will get the bitumen block bitumens. First you will heat the bitumen and then you will keep the bitumen in the beaker, and in room temperature you will conduct this experiment. It's not the temperature of bitumen is 25 degrees Celsius. In room temperature you will conduct this test. That is the meaning of it. Fine. Next one is float test. Float test. So generally when we are measuring, like penetration test, viscosity test, that means indirectly we are measuring consistency of the bitumen, right? So for certain materials for whom float, like penetration test and viscosity test cannot be done. That means if it is very softer, then we will be using float test to find out the consistency of the material. Fine. So it is used to find the consistency of the material, for whom it is used to find the consistency of the material for the materials for which penetration test and viscosity test is not possible. For which penetration test and viscosity test is not possible. Is not possible. Well, penetration test and viscosity test is not possible. So in this, what exactly you will be doing is, you will be taking an aluminum float, fine, we will be taking an aluminum float, with a brass collar. Okay, this is aluminum float, with a brass collar. Fine, what exactly we will be doing is, we will heat the bitumen and then we will cool the bitumen to 5 degrees Celsius. We will put that bitumen in this collar. We will put the bitumen in this collar. Fine, let us say I am putting that bitumen in this collar. We will put the bitumen in this collar. Will fill the bitumen in this collar, and I will keep this whole assembly in water. I will allow this whole assembly in the, I will put the whole assembly in the water, whose temperature is maintained at 50 degrees Celsius. Whose temperature is maintained at 50 degrees Celsius. Bitumen, this is water, fine. So water is at 50 degrees Celsius, whereas bitumen, this is bitumen which is at 5 degrees Celsius. Bitumen at 5 degrees Celsius. So what we are, I will keep this whole assembly in the water, and time taken by the water to pass through this, time taken by the water to penetrate into the float is measured. That represents the float value. Fine. So higher the float value means more is the amount of time taken by the water to penetrate, that means stiffer is the bitumen. Lower the float value means the bitumen is very, very soft. If you see, in penetration also we are measuring softness and hardness. In viscosity also indirectly we are measuring softness and hardness. Here also we are measuring softness and hardness. So if for the materials for whom penetration test and viscosity test cannot be done, we are going for float test. Fine. So in float test, what exactly we will be doing is, we will be taking an aluminum float with the brass collar at the bottom. The collar is filled with bitumen at 5 degrees Celsius, and then we will allow it to float into the water for certain amount of time, and then time taken by the water to flow into the float, right. That means it comes through this, and then it will float into the water. Time taken by the water to flow into the float is measured, and that represents the float value of the bitumen. Fine. So this is float test. In this test, an aluminum float with brass collar containing bitumen cooled at 5 degrees Celsius is allowed to float on water at 50 degrees Celsius. Is allowed to float on the water at 50 degrees Celsius. Time taken by the water to penetrate, time taken by the water to penetrate through the bitumen, time taken by the water to penetrate through the bitumen, time taken by the water to penetrate through the bitumen is measured, time taken by the water to penetrate through the bitumen is measured, and it represents float to penetrate through the bitumen into the aluminium float, through the bitumen into the aluminium float, into the aluminium float, aluminium float is measured, and it represents float value, and it represents float value. Higher is the float value, stiffer is the material. Higher is the float value, higher is the float value, stiffer is the material, stiffer is the material. Lower is the float value, lower is the float value, lower is the float value, softer the material, softer the material. Higher is the float value, stiffer the material, lower is the float value, softer the material. Fine, or material is soft. Any doubts in this? You can ask me. There is one dislike. Fine. Please do like, share, subscribe. Any doubts? Any doubts, guys? No doubts? Fine. Next one is, next property is specific gravity. Specific gravity test. Specific gravity test, you can use the same picnometer method that you will be you might have read in your geotechnical engineering, which I am not going to discuss it over here. So specific gravity test, picnometer method, from that you can measure the specific gravity test, and generally specific gravity of bitumen is in the range, it can be 0.97 to 1.02, whereas specific gravity of tar can be 1.10 to 1.25. If you see, specific gravity of bitumen can be less than 1. Can be less than 1 means it can easily suspend in water. Specific gravity of water is 1. So specific gravity of bitumen is less than 1 means it can easily float on the water, or density of the bitumen is less than density of the water. So the bitumen can easily float on the water. This is one of the important property the questions can be asked. So specific gravity of bitumen is lesser than the specific gravity of the water. So what I can say is bitumen can easily float on the water. That is specific gravity of the bitumen. Any doubts in this? You can ask me. Of course, whenever you are keeping a float, water tries to come upwards, buoyancy forces, water tries to come upwards, flow upwards, right? Whenever you try, if you go and immerse yourself, also sit yourself, water tries to push you, water tries to come like this, obviously. So that is the meaning. You are not pumping anything, but since you are putting something, water tries to go, water tries to push. Because of buoyancy forces, it tries to come upwards. moisture content property of the aggregates. What is the meaning of moisture content property, Narendra? That means water content. Water content, you will be discussing. Water absorption property I have discussed. Moisture content means what? Fine aggregates, moisture content, water content. You know how to find out moisture content, right? Weight of water upon weight of solids. Something confusing. What exactly you are talking? Please be specific in your question. Next one is softening point test. Softening point test. Softening point test. So in softening point test, what exactly you are going to measure? You are going to measure the temperature susceptibility of the bitumen. Temperature susceptibility of the bitumen. I said bitumen is less temperature susceptibility, whereas tar is more temperature susceptible. That means what happens with change in the temperature, how does bitumen affects? Obviously, if you increase the temperature, bitumen tries to flow. At what temperature bitumen is flowing, and what is allowed, what is not allowed, all those things we will be seeing here. So we are going to measure the temperature susceptibility of the bitumen. The apparatus used is called as ring and ball apparatus. The apparatus used is called as ring and ball apparatus. So in this, what exactly will be there is, there will be a brass ring with steel balls kept on an aqueous medium like water, or kept on an aqueous medium like water or glycerin, kept on an aqueous medium like water or glycerin. So what exactly we will be doing over here is, first there will be a container like this. This is a brass ring, or this whole assembly will be kept in the water at certain degrees temperature. Let us say room temperature, or I'll keep it at 25 degrees Celsius temperature. Fine. And there will be steel balls on the top of it. There will be steel balls over here. These are steel balls. Fine. So this is thermometer. This is thermometer. This is the brass ring. These are steel balls. And there will be bitumen in this. Fine. Now what I'll do is, I'll heat the bitumen. I'll constantly heat the bitumen. The temperature in the thermometer will be rising. Then what happens is, the bitumen is heated. This whole assembly is heated, bitumen is heated. Then what happens? Bitumen tries to flow like this. Bitumen tries to flow, and ball touches this level. This is certain height that is fixed over here. Fine. So the ball touches the lower frame. Time, now what you will be doing is, temperature at which this ball falls, is measured. That represents softening point of the bitumen. So if temperature, softening point is more, means temperature required for the bitumen to soften is more. So that means bitumen is less temperature susceptibility. If softening point is less, means at very small temperatures, bitumen can easily get softened. So it is more temperature susceptibility. Generally when we are constructing the roads, the temperature not necessary that it will be only 25 degrees Celsius, it can reach up to 50 degrees Celsius also on the roads. At the same time vehicles will keep on moving on it, so the temperature increases over there. So we try to find out at which temperature bitumen tries to flow like liquid. If it totally becomes liquid, then what happens is its water tightening property is lost. Right, idea of bitumen is what? Water tightening property as well as binder. So if softening point is less, it can be easily converted into the water, so water tightening property is lost. If softening point is more, that means it can't be easily converted into water, then softening point is high. That is the meaning of it. Fine. So softening point test. This is softening point test. It is used to measure, what I can write is, it is used to measure it is used to measure temperature susceptibility of bitumen. Temperature susceptibility of bitumen. It is used to measure temperature susceptibility of the bitumen. The apparatus used is ring and ball apparatus. The apparatus used is ring and ball apparatus. The apparatus used is ring and ball apparatus, in which a brass ring containing steel balls with bitumen is kept on water or glycerin is kept on water or glycerin. The apparatus is ring and ball apparatus, in which brass ring containing steel balls with bitumen is kept on water or glycerin, and temperature of water is raised. Fine. Softening point is the temperature at which bitumen is allowed to flow freely. Bitumen is allowed to flow freely such that steel balls falls through a certain distance. Fine. And steel balls falls to a certain distance. Higher is the softening point. Softening point bitumen is less temperature susceptible. Bitumen is less temperature susceptible. Lower bitumen is less temperature susceptible, and vice versa. Fine. Any doubts in this? You can ask me. That is softening point of the bitumen. Any doubts, guys? It is taken as adsorbed water. I have done water absorption test. Water adsorbed would be different, or bitumen adsorbed would be different. So please be more specific. Softening point test. Any doubts in softening point test? I can please go ahead and ask me. Any doubts in softening point? Softening point generally lies between softening point generally lies between softening point generally lies between 35 degrees Celsius to 70 degrees Celsius. 35 degrees Celsius to 70 degrees Celsius. Fine. This is softening point test. Next one is flash and fire point test. Flash and fire point test. Flash and fire point test. So if I try to see what exactly is flash point, flash point, I'll just discuss what is flash point, what is fire point. The test is not that much important thing over here. Fine. So what exactly is flash point is? It is the temperature at which bituminous vapors momentarily catches fire. That means it shows the flash. It will not be burned, like it will not be showing the fires, but it will just shows the flash. So it is the temperature at which bituminous vapors of bitumen momentarily catches fire is considered as flash point. So it is the temperature at which at which bituminous vapors momentarily catches fire. It is the temperature at which bituminous vapors momentarily catches fire. Generally it is taken as 175 degrees Celsius. Generally it is taken as 175 degrees Celsius. Next one is fire point. It is the temperature at which it is the minimum temperature at which bitumen is burnt. It is the minimum temperature at which bitumen is burnt. That is fire point. Flash point is the temperature at which bituminous vapors, the vapors coming out from the bitumen momentarily catches fire. It just shows the fire and then it goes off. Whereas fire point, it is the temperature at which bitumen is burnt. Like, totally it will be burnt. That is the fire point. Fine, fire point can be 1000 degrees Celsius also. Why it is important, sir? Why it is important? Because if there is fires coming out of the road, then all the vehicles gets disturbed. So we have to make sure that at which temperature the road has to be maintained. Fine, that is the idea. Anyway, 175 degrees Celsius, we can't survive. So generally saying that is the point. Okay, fine. Flash point and fire point test. Generally the apparatus used over here would be Penske-Martin closed and open cup apparatus. Penske-Martin closed and open cup apparatus. This is apparatus. What is the apparatus used for measuring this test? Is Penske-Martin closed and open cup apparatus. Generally, the the method and all those things is very big thing. I'm not discussing because that is not important from ESE point of view. Fine. So any doubts in this, you can go ahead and ask me. Any doubts, guys? Any doubts? Even though if it is basic doubts, please go ahead and ask. Any doubts? No doubts? Fine. This is flash and fire point test. Next test is spot test. Spot test. Fine. So this test is used to find whether bitumen is overheated or cracked. If bitumen is cracked, then when you are putting that bitumen on the roads, there is a possibility that small cracks will be developed on the top of it, which is also called as alligator cracks. Alligator cracks, generally on the body of the alligator there will be certain amount of cracks, right? The same type of alligator cracks you will be seeing over there. So in order to find out whether bitumen is overheated or cracked, we are going to do the spot test. Fine. So it is used to find out whether bitumen is overheated, or cracked. It is used to find out whether bitumen is overheated or cracked. In this, what you will be doing is 2 grams of naphtha plus 8 grams of bitumen. You will take totally 10 grams. 2 grams of naphtha plus 8 grams of bitumen. Fine. Totally 10 grams you will be taking, and you will put a dot on the white paper. You will just put a drop on the white paper. If rings like this are formed, clear rings, if clear rings like this are formed, then it is uncracked. Then bitumen is uncracked. If clear rings like this are formed, bitumen is uncracked. If not, if there is dark spot at the center, and then rings are formed something like this, let us say, then it is considered as cracked. Then bitumen is considered as cracked. This is dark spot. cracked, or this is so be considered as dark spot. If there is dark spot at the center, then it is considered as cracked. If it is clear rings, then it is uncracked. Fine. So here you will be adding 2 grams of naphtha plus 8 grams of bitumen. Fine. So any doubts in this, you can ask me. That is spot test. You will just fill that and you will put a drop on the white paper. If you are putting a drop on the white paper, if rings are formed, then it is uncracked. If dark spot is formed at the center, then it is cracked. Fine. Any doubts in this, you can go ahead and ask. Go ahead and ask. Safe limit for heating bitumen. Safe limit for heating bitumen means what? You can heat the bitumen generally at 100 to 125 degrees Celsius only. Like maximum at 175 degrees Celsius you will stop heating. You can't heat because there will be flash point, you will be seeing that. If you heat further, there will be fire point. So we try to avoid that. Generally 175 degrees Celsius is enough. Up to that you will heat and then you will mix it up, you will cool it and then you will put it on the roads. That is how you will be using it. So spot test, it is used to find whether bitumen is overheated or cracked, where you will be using 2 grams of bitumen, not 8 grams, 10 grams of naphtha. It's other way around, 2 grams of bitumen and 10 grams of naphtha. We will be taking less bitumen and more amount of naphthalene balls. If I add naphthalene on all those things, it becomes cut back bitumen. Okay. So this is the idea, spot test. Any doubts in this? Please go ahead and ask. Any doubts, guys? Any doubts? No doubts? Fine. Thank you. This is spot test. Next one is types of cutback bitumen. Types of cutback bitumen. Types of cutback bitumen. So in types of cutback bitumen, there are different types. Rapid curing cutback bitumen, rapid curing cutback bitumen, medium curing cutback bitumen, slow curing cutback bitumen. Curing means same as that of curing of concrete, the same thing over here. Curing would be very late. Fine. Rapid curing, medium curing, slow curing. Here the bitumen is fluxed with naphtha or gasoline. Bitumen is fluxed with naphtha or gasoline. Here the bitumen is fluxed with naphtha or gasoline, and bitumen is fluxed with, here the bitumen is fluxed with kerosene. How cutback bitumens are formed? By fluxing or by adding some volatile dilutant. So here you will be adding kerosene in it, here you will be adding naphtha or gasoline in it, and here bitumen is fluxed with bitumen is fluxed with high boiling point diluent. BP means boiling point diluent, high boiling point diluent. And in rapid curing also there are different types, RC0, RC1, RC2, that is rapid curing cutback bitumen 1, 0 rapid curing cutback bitumen 1, rapid curing cutback bitumen 2. So all these things, indirectly what it means is viscosity increases. Viscosity increases here. Fine. So viscosity keeps on increasing, 0, 1, 2, based upon the requirement will be using the bitumens. Fine. Next one is emulsified bitumens. Types of emulsified bitumens, if I see types of emulsified bitumens. Types of emulsified bitumen. If I try to see types of emulsified bitumen, then the different types in this would be rapid set, medium set, slow set. Rapid set emulsified bitumen, medium set emulsified bitumen, slow set emulsified bitumen. This is used for premixing with surface dressing. That means for topmost point for the surface we will be using this. Fine. For topmost surface we will be using this. So used for premixing with surface dressing. And then medium set is used for premixing with coarse aggregates. Mixing. Emulsified means this will be watery, so we will try to premix it, right. So used for premixing with coarse aggregates. And last one is used for premixing with fine aggregates. Fine. Used for premixing with fine aggregates. So these are different types of emulsifying bitumens. Emulsions means this will be watery in nature, so that you will keep on premixing it. With coarse aggregates you will keep on premixing with fine aggregates like subgrade, gravel, and then premixing with surface. Rapid set, medium set, slow set. Okay, this is emulsified bitumens, types of emulsified bitumens. Next one is types of tar. So in types of tar you will be seeing RT1, RT2, road tar 1. RT represents what? Road tar. Road tar 1, road tar 2, road tar 3, so on up to RT6, RT7 also it will be there. So indirectly what does it represents is viscosity increases. Viscosity increases. So RT1 is generally used for surface dressing. This is generally used for surface dressing or surface purposes. Okay, this is generally used for grouting purposes. What is grouting? You might have read in your college. Like whenever there are big holes in the tunnels and whenever you are working in the hydraulic structures, we just don't go put the concrete over there. We'll shoot the concrete by pipes. That is called as grouting, right? So for grouting purposes, generally if at all tar is used, then for grouting purposes you will be using road tar 6, and for surface dressing you will be using road tar 1. These are different types of tars. Fine. So any doubts up to here you can ask me. Which test you are asking, Akash Rani? Which test? There is no need of apparatus here. Just take 2 grams of bitumen and naphtha, and you will put this dot in a white paper. So you don't need any apparatus. Just put a drop on the white paper. If it forms in the form of rings, then it is uncracked. If it does not form in the form of rings, then it is cracked. That's it. You don't have to see anything else. Fine. So, any doubts up to here? So, what is meant by grouting then? Wonderful. See, gunneting is something like mixture of sand, cement, concrete and everything that is used. If it is used in the tunnels, then it is considered as gunneting. Fine. And the same thing, if you inject the small particles, if you are injecting very small thing into the soils, like if you are injecting the tar into the soil, or if you are injecting any other cement into the soil, if you are injecting concrete into the soil, if it is for small purposes, it is considered as grouting. If it is for bigger purposes, then it is considered as gunneting. Fine. Why I said like that is so that you can easily understand anyway. So when you are saying, sir, what exactly I want in depth, like what is here it is grouting purposes, where you will be injecting it. Fine. Injecting tar into the soil, injecting cement into the soil, injecting anything into the any other thing is considered as grouting. Gunneting, like you will be pumping the concrete. Fine. Now is it clear? So if you are not having any doubts, if you are having any doubts, please go ahead and ask. I will try to see some problems if possible. Fine. If you are having, do you have any doubts? Moisture content and water content, see, absorbed content and adsorbed content will be different. Adsorption means water that is present on the top surface, or bitumen gets adsorbed onto the water, or bitumen gets adsorbed onto the aggregates, whereas absorbed means water that is absorbed by the aggregates is called as absorbed. So moisture content or water content of aggregates both means like water that is absorbed by the aggregates. So water content, moisture content both means same. So I don't know where you have read, please be very specific. You can WhatsApp me, we can discuss that. Fine. So with this I am closing this session. If you are having any doubts, you can go ahead and ask. If not, this is Karthik Mandalapu signing off. Have a nice day. I don't know where it has been taken, Narendra. Please send me that. I'll discuss about it. And bye guys. Have a nice day.